Let's start the homework questions from section 4.5, applications of linear relations. And we'll start this homework video guide with question number 2. And for question number 2, I have a 4-year-old car that's worth $27,600, and it's going to be worth $4,200 after 10 years. For part A, I need to find the yearly depreciation of the car. So this yearly depreciation, this is the same thing as the slope. And what I've done already is I've constructed a table of values, and the table of values is one of the math tools that we'll be using quite often for the homework questions in this section. And then let's go ahead and fill in some of the points here. So the car is 4 years old, so when time is 4, the value of the car is $27,600, so $27,600. And then after 10 years from now, so that's 10 years from now, so we have to add 10 years, and if I add 10 years I get to 14, so after 14 years the car is now worth $4,200. Right, so that's how you would put the values into your table of values here, and the units for time are y for years, and the variable for value is going to be v. Okay, so what we're going to do here now is let's just write the coordinates here. So the coordinates are really 4, 27,600, and the other coordinate is 14, 4,200. Okay, and if you want to find the slope is really y2 minus y1 over x2 minus x1. So your y2 value is 4,200, so 4,200 minus your y1 value, which is 27,600, so 27,600. And then we divide that by the x2 value, and our x2 value here is going to be 14. So 14 minus our x1 value, which is 4. Okay. Now I would just go to your calculator here, and on the numerator you get negative 23,400, and on the denominator you get 10. And if you just go to your calculator, you get negative 2,340. And what this really means is you're losing $2,340 per year. All right, so the car is losing that much in value per year, and that's the yearly depreciation, which is the same thing as the slope. Okay, let's move on to question number B here. So for B, I've gone ahead already and I recopied the table of values, and I also have a basic grid set up there for the graph. And for part B, I need to write an equation that shows the value of the car V, and it depends on the new cost of the car. So new cost of the car is the keyword, and n, and so new cost has the value n, and how many years old is it using the y variable. So we have to write an equation here that relates this entire problem here. So going back to some of the data that was given to me early on, if I'm given this value right here, when we're at 4 years, the value of the car is about, let's just see, it's over here, it's 27,600. So maybe over here. Okay, and then after 10 years later, we're at 14 years. So at 14 years, roughly, let's put 14 over here to approximate, and maybe the value of the car is about here. So the value of the car is now 4,200. And I've kind of circled this other variable n here, the new cost of the car. So if I had to draw a line connecting the data here, maybe it looks like this. The y-intercept right here, this right here is the new cost. And hopefully that makes sense, because the new cost corresponds with the time of 0, right? So at the beginning, we want to know what the cost of a new car is, and that takes the value n. Okay, so let's go ahead and now that we kind of summarized the information there, let's go ahead and write the equation here. So we know the equation for any linear line is y equals to mx plus b, right? So we know that. So we just got to translate the variables to the variables that are used in this problem. So the question is, what represents the y value, or the y variable here? All right, so the y variable is represented by the v. All right, so it's going to be v equals to, then ask yourself, what is the slope? Well, the slope came from part A of the problem, right? Part A of the problem, and we were losing $2,340 per year. then ask yourself what variable represents the x. So what is x here? Well, x is time, and time is represented by years, right? So this y value, which is like over here, right? So it's going to be v equals to negative 2,340 y, and then plus the b. And what variable represents b? Well, b is the y-intercept, and it's using the letter n for this particular problem, the new value of the car. Okay, great. So that's your equation, and I think we're good for there. I guess in the back of the book, they kind of rearrange this. They write this as n and then minus 2,340 and then the y variable. All right, so there is your answer for that particular problem. Okay, let's move on to the next question, part C. Now the question is find the new price of the car. So here's my data, there's my table there. So if I have to redraw the graph here, the question is asking for the new value of the car. So basically we want to know the y-intercept. Okay, we want to know the value of the y-intercept. Okay, so let's go ahead and write out the equation that we had from parts, I believe it's from part C. So v equals to n minus 2,340 y. Okay, so our goal now is we need to find the value of n. All right, so there's different ways you can do this. I would go ahead and just use one of the values from your table here. So maybe we can use this value right here, 14, 4,200. And let's plug that in. So that means the v would now be 4,200 equals to n minus 2,340. And what's the value of y? The value of y is 14 years. Okay, and then from there we just solve for the n variable. All right, so let's do that. So that's 4,200 equals to n. And if I go to my calculator and compute this, 2,340 times 14, that's going to be 32760. All right, so 32,760. And then let's go ahead and solve for n by adding this. If I bring this to the other side, we add it to 4,200, and if I do that, I get 36,960 as my new value of my car. Okay. All right, so if I went back to my table here, what that really means is when time is 0, the new value, or at the very beginning, the new value of the car is $36,960. Okay, perfect. And let's go ahead and move on to the last question, which is find the domain and the range. Okay, so we just figured out from part C that at the beginning, the value of the car has a worth of $36,960, and we want to find the domain and the range. Okay, so what we're going to do here is I'm going to answer this question using a table of values. And from part A, I know that my slope is negative $2,340. Okay, so after 1 year, the car will depreciate in value, and we're going to minus $2,340. So after 1 year, the car is now worth $34,620. Then after 2 years of driving, the car is going to once again depreciate one more time, and we're going to lose another $2,340. And now the car is worth $32,280. And after 3 years, let's just go ahead and subtract another $2,340. Then after 3 years, the car is worth $29,940. Okay, so obviously I can keep on going forever. So my domain is really representing my x values, and my x values are my time values, right? So 0, 1, 2, 3 on forever. So my domain would be 0, 1, 2, 3, and then dot, dot, dot going on forever. And my range is simply my y values, and my y values in this case are represented by the green numbers here. So 36,960, 34,620, 32,280, and I got 29,940, dot, dot, dot. Eventually the car will have a value of 0, but I won't write out all the values, but that would be my range for that particular problem. Okay, let's move on to question number 4 now. I got an apartment building that's worth $860,000, and the owner expects the property to double its value over the next 5 years. Find the yearly increase of the apartment. Okay, so part A is asking for the slope. So a yearly increase of the apartment, that's basically, yeah, that's the slope. And let's go ahead and fill in this table of values here. So when we're at the start, at the beginning, the apartment has a value of $860,000. Okay, and then it doubles after 5 years. So when we're at 5 years, the value of this particular condo will double, and if I double that, it's gonna be $1,720,000. Okay, so let's go ahead and find the yearly increase of the apartment, and we can simply do that by finding the slope. So basically my coordinates I have are 0, $860,000, and the other coordinate I have is 5, $1,720,000. And let's go ahead and find my slope here. Now my slope is the same thing as from the previous questions, rise over run, which is the difference in the y values. So here are my y values, so I will subtract those. So $1,720,000 minus $860,000 all over, and then I go from the 5 to 0, so 5 minus 0 on the denominator. And feel free to just go to a calculator for that. I get $172,000, and that is, and the units are dollars per year. Okay, so basically what that means is that the apartment is going up in value by $172,000 per year. Okay, so if I go back to my table here, if I go back to my table here, if I go to the next year here, basically I'm just adding $172,000. All right, and if I do that, my new value after 1 year will be 103, 2, and then 4 more zeros. All right, so basically over $1 million, so $1,320,000 there. So that's how much the value of the apartment would be after 1 year. Okay, but this is the answer for part A. That is my slope. That is the yearly appreciation value there. Okay, now for part B, the question is asking what was the value of the apartment 3 years ago if the rate increase is constant. So 3 years ago. Okay, so let me go back to my table of values here, right? So this is how much the apartment was worth at the beginning. All right, so we want to know how much was the apartment worth 3 years ago. So if I go backwards now, backwards means like this is like -1 year ago, 2 years ago, 3 years ago. So I want to find out how much is the apartment worth 3 years ago. Okay, so in order to do that, we just go backwards like that, and we just subtract $172,000. All right, and if I do that, I get $688,000. If I want to go to 2 years ago, I subtract another $172,000, and I get $516,000. And if I finally want to go back 3 years ago, I take away another $172,000, and I get $344,000 there. Okay, so that is my answer for part B. Okay, and okay, let's move on here. I guess actually part C. I guess I'll start with part C too now. Part C is asking for the domain and the range. So the domain, since I have my table of values here, I can just use the values I have. So the domain is represented by the x values. So I'll just use the values I have here. So -3, -2, -1, 0, and +1, and we keep on going forever. And then the range. Okay, so what number corresponds with -3? Well, it's $344,000, and then $516,000, and then $688,000, and then I guess the last one here would be $860,000, and then we would keep on going on forever, right? So plus ... Okay, so that's one way where you can write your domain and range based on the values that we've been using in our problem. Okay, great, that's good stuff. Let's move on to the next one here. Let's move on to